Hey everyone, welcome to this section. Here we are going to give you an introduction to IP routing overview. So before we proceed with any routing configuration on any of the platforms, which could be Cisco, which could be Juniper, Palo Alto, right, or any of the next gen firewall vendors, you must know the basic fundamental principles of routing. Um, so let's talk about it. So IP routing, generally it is the process of forwarding a packet from a source to a destination across any interconnected networks. So let's say that we have got uh, certain routers. So let's say I've got a single router, okay, so which could be any vendor, which could be a Cisco router or a Juniper router or any device, right, which is basically a layer 3 device. It could be a layer 3 switch as well. It could be a layer 3 firewall as well. And firewalls by default, they are routed device, right? So basically their job is to connect or interconnect multiple networks together, okay, and allow the traffic to traverse through multiple network. Let's say it has got couple of interface connecting to two different segments, and over that two different segments I have got certain devices connected. Let's say I've got couple of end hosts connected on that two different segment, and they are on two specific network address. Let's say this is 10.0.0.0 slash 8, or let's say being a classless 10.1.1.0 slash 24, and say this is 172.16.1.0 slash 24. Okay, so as a basic thing, I should know that IP routing is generally it is the process of forwarding a packet from a source to a destination across any interconnected network. So it will ensure that the data will travel efficiently across the network using routers and by using routing protocols. Okay, so this router will have let's say it's connected interface, which is example this is a fast Ethernet 0/0. That's the interface name. Let's see over here it is F0/1, and this router will maintain a routing table provided it has got an IP address configured on this interface respectively. Let's say we allocate the IP address over here as 10.1.1.10, and as per the subnet mask it should be /24 mask. Likewise over here we have configured 172.16.1.10 as an IP, and this is the mask. So whenever you go and configure an IP and a mask to a router interface or an L3 device interface, it will keep those entries in its interface table, plus it will also keep those entries in its IP routing table. Okay, we call that as IP routing table. Okay, so it will have right now the routes labeled as connected routes because they are directly connected to its segment or to its interface, and it will be labeled like 10.1.1.0/24 is directly connected via, and you will find the interface name which is F0/0. Likewise I'll have 172.16.1.0/24 is directly connected via F0/1. Okay, now this router whenever any packet arrives to its interface, so when a device sends data it will place the destination IP address in the packet header. So let's say this device its IP address over here it is 10.1.1.1/24, and this device has got a MAC address. Say the MAC address is quadruple A, starts with quadruple A. MAC is of 48 bits we know, and let's say the first four values I wrote here. Okay, and likewise this device has got an IP address of 172.16.1.1/24, and let's say this device MAC is quadruple B. starts with quadruple B, right? So let's say that whenever this device, the sender is MAC A and the destination is MAC B, so when the device sends any data, it will place the the destination IP address in the packet header, the source IP address of the, so it will create the data, okay, and then the data will be encapsulated by different layers of your OSI model, as you know. But at layer 3, the source IP address would be populated. So source IP address would be 10.1.1.1, and the destination IP would be populated, which is 172.16.1.1. okay, and further you'll have the source MAC at layer 2, which is going to be quadruple A, and the destination MAC address, which will be so the thing is very simple. If we'll do ARP now, address resolution protocol will come in the picture. So the source device will do an ARP resolution to find out the MAC address of its default gateway. So definitely you will place this particular device, you will configure it with a default gateway IP on its LAN segment, as the router IP will be its default gateway IP. I write that as DG. Likewise, this device, its DG or its default gateway would be the router IP, which is 172.16.1.10. right now, this device, the source device, will do an address resolution protocol or the ARP process to find out the destination MAC of the default gateway IP, and let's say the MAC address is the MAC address that is lying on F0/0 interface. Okay, all right. So the whole idea is, when this particular packet, it arrives on the routed interface from that user, this particular router would find out the destination address in the packet, and it will find out the best path to forward the packet using its routing table. So it will find out that, okay, I know regarding the destination IP 172.16.1.1, I find a match with my routing table, and this is right here. It is directly connected on F0/1 interface, and before it forward this particular packet out to the destination, the router will again do an ARP process to find out the destination device MAC address and do a layer 2 MAC address rewrite, right? So this is a very important process where it should go for the layer 2 MAC address rewrite process, where it will swap the destination MAC address with the actual MAC address of the device, or the destination device, right? So what will happen is, the packet, before it is thrown out of the router, the data content will remain the same. Source IP will be again 10.1.1.1, destination IP will be again 172.16.1.1, but the MAC address would be changed. So source MAC will be the F0/1 MAC address, which is there on the router interface, and the destination MAC address, after doing the ARP process, it will come to know that the MAC address is quadruple B, starts with quadruple B, right? So yeah, so this is the way a packet travels from one destination, to a destination, traversing one network to another network through a router. And similarly, the return traffic will also take the same process, right? Now these routers will have a routing table. So routing table is basically, it's a database in a router that stores the information about the available networks, and there can be different types of information that can be there in the routing table. All right, so the different types of information that can be there in the routing table. So a route can be populated in the router by various means that I want to say. So first is directly connected routes. Okay, so this is the interface on the router which is attached to that particular network segment. Okay, likewise, you'll have static routes. So manually you can go and configure static routes and define the network addresses that the router can connect to, right? And define the gateway through which the route can be reachable. So it is a manually configured routes that I can say. Likewise, you'll have dynamic routes. right? Dynamic routes which will incorporate routing protocols. So routers will learn the routes via dynamic routing protocols, which could be of various types, okay, like RIP, like Cisco proprietary protocols like EIGRP, or open standard protocol like OSPF, ISIS, BGP, right, etc. Okay. Yep. Similarly, I can say that each routing, so whenever the entries are filled into the routing table, we call that as a routing entry. So each routing entry will consist of some few information. So it will have the destination network, right? It will have the destination network where the packet should go. It will have the next hop information, next hop IP address information, which will be the gateway through which the destination network could be reachable. It will have the metric information, right? That means the cost value which is associated to choose that best path, right? And as well as the outgoing interface information. If it is not there, then the router will do recursive routing process to find out, what should be my outside interface or what should be my outgoing interface to reach to that particular destination network. Okay, so an example of, let us say, a static route. Let's say if you want to configure a static route, example could be, let's say IP route, let's say 15.1.1.0, define its subnet mask, and then you can define the gateway. Say for example this is 1111 as the next hop address. So this is the network, this is the subnet, this is the subnet mask, and that's the next hop IP or the gateway through which this route is reachable. Likewise, if you want to configure a static default route, it will be IP route followed by any IP followed by any mask, and let's say the gateway as an example, right? So any IP any mask combination is normally called as the default route. Okay, so yeah, similarly, you can use dynamic routing protocols, as I've told you. So dynamic routing protocols can be of multiple types, which will automatically help the router to find out the destination network and help the router to learn those destination network via the dynamic routing protocol mechanisms, right? The common protocols that we use are RIP, that is routing information protocol, which is basically a distance vector protocol, right? And it is going to use the hop count as the metric, right? So it uses the hop count feature as its metric, right? Likewise, you have the protocol which is basically OSPF, which is very common, that is open shortest path first, and it is a link state routing protocol, and it is going to use the link cost parameter as the metric, right? This is about OSPF as a very high level overview. Likewise, we have EIGRP, that is Cisco proprietary protocol, which is advanced distance vector protocol again, and it uses it is called as enhanced interior gateway routing protocol, and it uses composite metric of a particular link, like bandwidth, delay, reliability, load, and MTU features of a particular link to calculate a best path to reach a particular destination network. So I can say it uses composite metric. Okay, and likewise you have another protocol which is a favorable protocol for internet, that is border gateway protocol, or BGP. It is used for internet routing. Okay, then BGP uses path attributes as the parameters to decide a best path. There are multiple path attributes that BGP takes to choose upon a best path. Okay, so yeah, as I've told you, IP routing is very essential for data communication across the networks. Whether you are using static routes or dynamic routing protocols, routers, they rely on the routing tables, okay, and it will use the protocols to efficiently forward those packets. And understanding these concepts will definitely help in designing and managing your network infrastructure very effectively. So that's it, what I can say as of now over here. So make sure that you have the right IP routing knowledge with you, and if not, then we can look into our CCNA and CCNP courses, and you can be familiar with the various IP routing technologies that we have, and the different configuration, the different scenarios that we discuss, and be acquainted with the right routing knowledge. All right, so I hope you possess the same, and you have got the idea regarding what is routing is all about basically, so we can take this discussion in our next lecture. Thank you so much, and I'll see you in the next video.